Welcome to an introduction to educational research. Today's video deals with the single case research designs, a multiple baseline design, and a multiple probe design. As we've stated in previous videos on single case research designs, some research questions are not suitable for the traditional true experimental or quasi-experimental research designs, because these designs usually require large samples, or at a minimum, if you're using two groups and you cannot have large samples, at least an equivalence between the groups, whether it's experimental and control or more than two groups. You need to have the groups be equivalent on whatever is being measured. So a series of single case experimental designs have been developed which can establish experimental control of the independent variable over the dependent variable and allow for very good validity, internal validity to the references and inferences made from the data. Now, as we've already discussed also, these designs are based on two assumptions. One is baseline stability. So all single case designs have a baseline phase or baseline part. And when baseline data is collected, it needs to be stable in terms of its level and its trend and its variability before you can intervene. And that is based on the idea of what's referred to as baseline logic. Now, baseline logic states that if a behavior has stabilized in the baseline condition in terms of its level and its trend and its variability, if it's stable, then that we can assume the behavior has reached its natural level in the environment and is being sustained by the environment. And if there is no change to the environment, if there's no intervention of some type, the behavior will remain at that level. So you need to have baseline stability so that the assumption of baseline logic can sort of kick in. Now, there are some exceptions to having a stable baseline. So as an aside, if you're dealing with a behavior that is extremely dangerous to the participant, let's say a student is a headbanger, or let's say a student is displaying aggression towards classmates or towards themselves, well, then it would be unethical to wait for a stabilized baseline. You would just go ahead and intervene. But generally, all other factors being equal, you need to have a stable baseline data so that the assumption of baseline logic can kick in. Now, in the previous video, we've presented the AB single case research designs, and these are excellent designs that can establish experimental control of the independent variable over the dependent variable. And they are very easily conceived and implemented in classroom or clinical settings. The one major disadvantage of the AB designs is that they're not effective with behaviors that are learned or cannot be reversed. If the behavior can't be reversed, then there can be no withdrawal condition. So if you wanted to teach, let's say, single-digit multiplication facts to a student or a group of students, you couldn't use an AB design because once the student has learned the multiplication facts, they're not going to unlearn them in the withdrawal phase. So we need designs then that can deal with behaviors that need to be taught and that can be learned and not reversed. And so there is such a design, and this video deals with a multiple baseline and multiple probe design. And both of those are designed to be used with behaviors that are learned and cannot be unlearned. Okay, now let's just take a look at the big picture. Well, actually, this is only half of the big picture. So on your screen, you see types of educational research in the blue box. And then on the quantitative research side of that blue box, we have experimental research designs and non-experimental. And under the experimental designs, we have true experimental, quasi, pre-experimental. And then we have single case designs. And we have the AB design, which we've already done. And now we're looking at the two with the white circle around it, the multiple baseline and multiple probe designs. So that's where we are in terms of the research designs. Okay, now let's take a quick look at just an AB design. Okay, so here we have an experiment, the effects of extra computer time on in-seat behavior. And we have baseline data, and then we have an intervention, which is the extra computer time. And you can see that the baseline data eventually stabilized. And once it stabilized, then there was an intervention. And we'll assume the data moved in a therapeutic direction. So this is an AB design. By its very nature, it's extremely weak and pre-experimental type of a design, with many threats to the internal validity or inferences drawn concerning the results of this design. Well, suppose we did this. Suppose we did another intervention. Now we have two AB designs, and both have stabilized baseline data and an intervention, and the data has moved in a therapeutic direction. Now, what can we say about the relationship between the behavior being targeted, which is in-seat behavior, the dependent variable, and the intervention, which is the extra time on the computer, which is the independent variable? Well, actually, we can't say anything. As stated above, this is an AB design, and it is extremely open to threats to internal validity and the inferences drawn from the data. Just because we have two very weak designs doesn't improve anything. Now, from a researcher's point of view, we could have 5, 6, 7 AB designs stacked up on each other, and it still would not improve the situation. Now, granted, that's from the researcher's perspective. From the teacher's perspective, well, this is fine. The teacher's not necessarily interested in generalizing the results of the study, but data has moved in a therapeutic direction. However, since we are researchers, this type of design is of no use to us. Well, let's see if we can then come up with a design that may be useful for us. Well, okay, now let's suppose we have a situation like this. We have 4 tiers. And we have on the top, you can see an independent variable is a constant time delay strategy, and you'll learn more than you want to know about that in a little bit. And on the bottom, in the yellow box, you can see the behavior is the acquisition of multiplication, single-digit multiplication facts. And we have 4 tiers, and you can see on the very left side of each tier, we have S1, which stands for student number 1. We have S2, which stands for student number 2. S3, which stands for student number 3. And S4, which stands for student number 4. Now, let's suppose we have to take baseline data. Now, this is multiplication facts. So let's suppose we've given all 4 students a test on the single-digit multiplication facts, and we've come up with sets of facts that each student does not know. Now, the sets of facts that each student does not know may differ a little bit. Student 1 may know certain facts, and student 2 may not know them, and so on. So and let's say we'll work with 10 problems. So each of them has 10 multiplication facts that they do not know that we're going to try and teach them. And we'll take baseline data. So we've taken baseline data for all 4 students, and the data is stable in terms of its level, its trend, and its variability. And basically the 4 students obviously don't know the multiplication facts. Well, okay, now let's intervene. Now we can intervene. Now look what happens here. In this design, we intervened in tier number 1. And the data moved in a therapeutic direction, and it reached competency at all 10 facts being correct. But notice we did not intervene in tier 2, we did not intervene in tier 3, and we did not intervene in tier 4. So they stayed at baseline level. Well, that means now we can intervene in tier 2 because the data is stable. Well, now we've intervened in tier 2, and notice that in tier 2, the data has moved in a therapeutic direction. Notice in tier 1, we took some probes to see that the student in tier 1 still maintained the information that they knew, and they did. We did not intervene in tier 3, but we continued to take baseline data, and we did not intervene in tier 4, and we continued to take baseline data. And the data is stable in tier 3 and tier 4. So now we can intervene in tier 3. And lo and behold, we've intervened in tier 3. The data moved in a therapeutic direction. It reached competency. We took probe information in tier 1 and in tier 2, and both students remained at 100% competency. We did not intervene in tier 4, and therefore, the baseline remained stable. So now we can intervene in tier 4. Well, okay, now the same thing happened. Once we intervened, the data moved in a therapeutic direction to competency. We probed in tiers 1, 2, and 3, and those students still remained at 100% competency. So this design, the way it is laid out, is picture perfect. It demonstrates very strong experimental control that the independent variable, the constant time delay, is responsible for the change in the dependent variable, which is the acquisition of multiplication facts. And the reason is that only when the intervention was introduced did data move in a therapeutic direction. We intervened in tier 1. We did not intervene in tier 2, tier 3, and tier 4. Then we intervened in tier 2 because the data was stable and tier 1 had moved to competency. But we intervened in tier 2 in what is referred to as a time-lagged fashion. A time-lagged fashion. So there was a time lag between the intervention in tier 1 and in tier 2. And the same with tier 3. There was a time lag. And only when we intervened in tier 3 did the data move in a therapeutic direction. And the same in tier 4. So this is a classic multiple baseline design across students. Now, you can have a multiple baseline design across behaviors also. Take a look at the tier, under tier 1 on the left-hand side, and you'll see B1, which means behavior 1. B2 is behavior 2. B3 in tier 3 is behavior 3. And in tier 4, B4 is the behavior number 4. So you can have 4 different behaviors from the same student. Or keep your eye on the tiers on the left. We can have settings. We can have 4 different settings. So let's say C1 stands for class number 1, C2 class 2, C3 class number 3, C4. So you can use this multiple baseline design with different students, or different behaviors with the same student, or different settings with the same students. So it's a very useful design, relatively easily conceived, and very useful for classrooms. Now, Let's take a look at some possible threats that this design can have. One of the first threats is a situation like this. Okay. Now, this is an example of covariation, which means that the behavior is not functionally independent. So take a look at tier 1. We intervened, we took baseline in tier 1 and tier 2 and tier 3 and tier 4. And at the baseline level, it's very stable in all 4 tiers. And then we intervened in tier 1, and the behavior moved in a therapeutic direction till it reached competency. In tier 2, the same thing. We intervened. The baseline was very stable at the beginning. Once we intervened, the data moved in a therapeutic direction and remained at competency. But take a look at tiers 3 and tier 4. In baseline, it was stable initially, but then the behavior started to drift up and move in a therapeutic direction with no intervention. And the same in tier 4. The data moved in a therapeutic direction before we intervened. So this means this design does not demonstrate a good functional relationship between the independent variable and the dependent variable. The independent variable is not responsible for the change in the dependent variable because in tiers 3 and 4 we did not have total stabilized baseline data. The data started to move in a therapeutic direction. So that threat is referred to as covariation. The second threat will look something like this. Tier 1 and Tier 2, baseline data is stable. We intervene in Tier 1, moves in a therapeutic direction. Everything is hunky-dory. Same in Tier 2. Baseline is very stable. We intervene. The data moves in a therapeutic direction to competency. Tier 3, we have stabilized baseline data. We intervene, but the data does not move in a therapeutic direction. It moves up and down, up, and then eventually in a contra-therapeutic direction. And take a look at Tier 4, we have the same situation. Baseline is very, very stable. Once we intervened, the data went up a little bit and then it went down and back to baseline level. This is an example of an ineffective or weak intervention. The behaviors are not functionally similar. So these two, the covariation and the weak intervention, present huge threats to the multiple baseline design. Now, let's take a look at what is referred to as a multiple probe design. And we're going to use the multiple probe design to offer an alternative to the amount of data that needs to be collected in the multiple baseline design. An awful lot of data has to be collected in the multiple baseline design. So here's how a multiple probe design works. Just like any single case design, we have to take baseline data. So we'll take our baseline data. It's stable in terms of its level and trend and variability. So we can intervene in Tier 1. Now notice we intervened in Tier 1. But notice we did not take any data in Tier 2, Tier 3, or Tier 4. We didn't take any baseline data in Tier 2, Tier 3, and 4. Now we'll take baseline data in all of them. And when you see in Tier 1, the data has reached competency and is leveled out. But in Tier 2, its baseline is the same. Tier 3, it's the same. Tier 4, it's the same. Now, let's intervene in Tier 2. Now notice we only intervened in Tier 2. We didn't take any data in Tier 3, Tier 4, or Tier 1. The data in Tier 2 moved to competency, moved in a therapeutic direction. Now we take baseline data in all of them. Notice that in Tier 1 and 2, the data remains at the competency level of 100%. In Tier 3 and 4, the baseline is still very stable at initial baseline level. Now we intervene in tier 3 only. Same thing. Data moves in a very therapeutic direction to competency. We do not intervene in tier 1, tier 2, or tier 4. Now we'll take baseline. Tier 1, 2, and 3 remain at 100% competency, and baseline in tier 4 is still at the initial baseline level. So now we can intervene in tier 4. It moves to therapeutic direction to competency, and tiers 1, 2, and 3 remain in competency. Now, the multiple baseline design is an alternative to the multiple probe design, and it allows you to collect less data. It allows you to collect less data because you have an initial baseline, and if everything is stable, then you intervene in tier 1, but you don't collect data in tier 2, 3, and 4. Then you collect baseline data from everything. Then you go back to tier 2 and you can intervene in tier 2, but you don't collect data in the other tiers, and so on. So again, a very simple design, easily conceived and easily used in classroom settings. Both the probe and the multiple baseline designs are easily planned, as I said, and implemented, and can establish strong experimental control. And along with the AB designs, they are excellent tools for practitioners to have in their toolboxes. Well, okay. Now, here's your assignment. I'd like you to use the internet, research articles, textbooks, whatever you can find, and research the response prompting procedure, which is called or referred to as constant time delay, or CTD. Now, write a narrative about the constant time delay procedure, the rationale for the strategy, how the data collection works, and how it might be used in a classroom setting. Second, I'd like you to create a hypothetical research study that uses either a multiple baseline or the multiple probe research design. Use constant time delay strategy as the independent variable and the acquisition of single-digit multiplication facts as the dependent variable. List the title of the research, the independent variable and dependent variable. Create dummy data and present the results in graph form or in table form. And as always, just add your responses to the document you're creating for this assignment, and then when you're done with the entire assignment, please email me your results. Well, here are the resources that were used to put this video together. Thank you very much, and we'll see you in the next video.